Hey guys, this is Mrs. Harbin, and today we are moving on to 3.5a, dividing radicals. You see there's an A, which means there will also be a part 2, a B. Now for some of you this might be a challenging lesson because you're going to be taught a new skill that you maybe have never learned before. Some of the other things we've done are just kind of a refresher from Algebra 1 or Geometry, but for some of you today's stuff is going to be new. So make sure you're pausing when you need to pause, taking notes, writing down any questions, and make sure that you understand each step of the example problems that we're doing. If there's something that you don't understand, it is your responsibility to write that down and make sure that you ask me and follow up in our next class. Let's start with some simple things here. Let's simplify root 9 over root 4. Hopefully you recognize that both of those are perfect squares, and you can just take the perfect squares or the square roots of this. So the square root of 9 is 3, and the square root of 4 is 2. So when simplified, we get 3 over 2. What about the square root of 16 over the square root of 25? Hopefully, again, you recognize those perfect squares, and you know that that simplifies to 4 over 5. Try these next two on your own. Pause the video, and then resume when you're ready to check your work. Alright, hopefully you again recognize these as perfect squares, and you saw that the square root of 49 divided by the square root of 36 is just 7 over 6, and the square root of 64 over the square root of 121 is 8 over 11. If you are still struggling with your perfect squares, make sure that you spend some time learning those square roots and perfect squares. You should know that 7 squared is 49, and that the square root of 49 is 7. You should know that 8 squared is 64, so 64 is a perfect square with a root of 8. So make sure you learn those all the way up through 15. Obviously, you can learn more, but the first 15 perfect squares are the ones that you'll see the most frequently in the work that we are doing. All right, try this one on your own. And hopefully simplify that to 10 over 9. Our application for this unit continues to be that God blesses His people with abilities and skills to succeed in their life work to His glory. You heard me mention at the last presentation that we are told throughout the Bible to add knowledge and add wisdom. None of us know what we're going to end up doing exactly in life or what we're going to be called upon to do to solve a particular problem. So we need to add to our skill set as much as possible so that we can do the work that we have been called to do. Our lesson objective for today is this: you, the student, will divide expressions that contain radicals. Let's review that product property of radicals here. Product meaning that we're multiplying. And our product property of radicals says that for x is greater than or equal to 0 and y greater than or equal to 0, that if we're given the product, we can separate it into its factors. Or if we're multiplying two factors, we can write that as one product. The thing that is important to remember is that when we are multiplying, our indexes do need to be the same. That's going to lead us to the quotient property of radicals. Quotient meaning division, and that's what we're working on today. The quotient property of radicals says that for x is greater than or equal to 0 and y is greater than 0, we have a fraction as our radicand. What we can do is separate that fraction into two radicals. So if we're taking the root of x over y, we can separate that into the root of x over the root of y. Okay? Or conversely, if we're given two separate radicals, so we can rewrite it as one radical with a fractional radicand. So we can go either way. And that is our quotient property of radicals. So let's see this with some numbers. We're going to simplify the square root of 40 divided by the square root of 5. The first thing we want to do is write that as a fraction. So this is the square root of 40 divided by the square root of 5. Our quotient property says we can write that as one radicand, a fractional radicand. So we're going to rewrite that as the square root of 40 divided by 5. 40 divided by 5 is a simple division problem that you can do mentally, and you should then get the square root of 8. Now we're not quite finished. We do need to see if 8 can be simplified by looking at our prime factorization or looking to see if there are any factors in 8 that are perfect squares. And even though we've got the final answer here, We know that 8 is the same thing as 4 times 2. 4 is a perfect square. That's the same thing as square root of 4 times the square root of 2. The square root of 4 is 2, and the square root of 2 just stays as it is. So our most simple answer here is 2 square root of 2 when we divide root 40 by root 5. And what about square root of 15 divided by the square root of 12? Again, our quotient property says we can write that as 1 radicand, a fractional radicand, so we're going to rewrite that as square root of 15 divided by 12. 15 divided by 12 is a fraction that simplifies, and it simplifies down to the square root of 5 over 4. Now, as long as we have a fraction as our radicand, we're not done yet. We've got to keep simplifying because we don't want to have a fraction as our total radicand. So we're going to split this back up now into square root of 5 over the square root of 4. The reason I've done that is because I recognize that 4 is a perfect square. And so I can simplify that and get the square root of 5 over 2. Now this is a simplified answer. Even though it does have a fraction, the 2 is not part of the radicand. So here, both the 5 and the 4 were part of the radicand, so it was not completely simplified. We want to simplify it so that, even if we have a fraction, our denominator is not part of the radicand. So when simplifying radicals, again, here's kind of what I was just saying, fractions with radicals in the denominator or radicals with fractions in the radicand are not considered to be simplified. Here's what those two things are saying. Fractions with radicals in the denominator. Let's say you have 5 over the square root of 2. This is a fraction and it has a radical in the denominator, but it is not simplified. We're going to have to do something to simplify that. Or, like the previous one that we just saw, radicals with fractions in the radicand. So we have a radical, and underneath that radical symbol we have a fraction. So radicals with fractions in the radicand are not considered to be simplified. So we need to do something with both of those to make sure they are simplified. So here are two examples. 1 over the square root of 2, that's an example of our first one here, and the square root of 2/3 is an example of our second one here. While those are not necessarily bad, they're just not in their simplest form. So we need to do some work there to get them in their simplest form. The process of removing radicals from the denominator of a fraction is called rationalizing the denominator. Rationalizing the denominator. This goes back to the different types of numbers that we have. We have real numbers and imaginary numbers, and under real numbers we have rational and irrational numbers. 1 over the square root of 2 is an irrational number. So we want to fix it. We want to make it rational by rationalizing the denominator. This is the part that is going to be new for some of you, so please pay careful attention to the steps, write them down, make sure that you go back and watch the video, repeat anything that doesn't make sense so that you can follow along step by step. So let's take a look at square root of 5 over the square root of 7. If I write that as one fraction, one radicand, the square root of 5 over 7, it doesn't simplify, so there's no reason for me to do that. But I know it's not completely simplified yet because I have a radical in the denominator. I need to get that radical out of the denominator. So think for a second, how do we get rid of a square root symbol? What's the inverse of taking the square root? Hopefully you said the inverse of square root is squaring. So in order to get rid of this square root of 7, we're going to have to multiply it by itself. The square root of 7 times the square root of 7 should get rid of that radical symbol. The square root of 7 times the square root of 7 is just 7. Now we can't just multiply the bottom, because whatever we do to the bottom, we also have to do to the top. So we have to also multiply the top by the same thing. Now here's a quick question. Back when you first learned about fractions and division, you learned that anything divided by itself is equal to what? Hopefully you said 1. So 3 over 3 is 1, because 3 divided by 3 is 1. 16 over 16 equals 1. And also, that's true also with radicals. So the radical 7, the square root of 7 divided by the square root of 7 is 1. So all we're really doing is multiplying this by 1. Our 1 just looks a little bit different because what we want to accomplish is to get this radical out of the denominator. So we multiply both the top and the bottom by a root or a radical that will help us rationalize this denominator. When we do that at the top, when we multiply fractions, we just multiply numerator times numerator, and we multiply denominator times denominator. So square root of 5 times square root of 7 is the same thing as the square root of 35, and square root of 7 times square root of 7 is 7. So it's really looks like this under the radical, and then we're like, oh, there's 2 here. So it comes out for using our prime factorization method here. So that's why we have only a 7 left. Now, is this as simple as it can be? Think about 35 and its prime factors. Its prime factors are 5 and 7. So we really can't simplify that. All right, let's take a look at this one. Square root of 3 divided by the square root of 6. Now, if I write this as 1 radicand, I would have 3 divided by 6, and I know that that can be simplified. So let's do that first. Let's rewrite that as 3 over 6, which simplifies to 1/2. Now, this is not the simplest answer because I still have a fraction as my radicand. So I'm going to break it back apart into the square root of 1 over the square root of 2. Again, this is still not the most simplest or the simplest form because I have a radical in the denominator. So how am I going to get rid of this root 2? Well, I get rid of root 2 by multiplying it by itself. And if I multiply the bottom by root 2, I have to multiply the top by root 2. Going across the top of my fractions here, I have the square root of 1 times the square root of 2. That's just the square root of 2. And on the bottom, the square root of 2 times the square root of 2. It essentially, the square undoes the square root, and so we just have a 2 on the bottom. Square root of 2 over 2. And that is it. I can't do anything else with that. I cannot reduce these. I can't take 2 divided by 2 because this, remember, is not actually 2. It's the square root of 2. We can't just ignore that sign. All right, try this one on your own. See if you can figure out how to do it. Pause this video while you try. Come back and check your work. All right, I know that 2 divided by 75, if I were to write that as 1 radicand, isn't going to reduce. So we're just going to go ahead and start the process a little bit differently. Now 75 is a pretty big radicand. And I know that the factors of 75 are 25 and 3. So I'm going to go ahead and simplify the square root of 75 and rewrite that as root 2 on the top and write my bottom as 5 square root of 3. Now I can go ahead and move to rationalizing the denominator. Now if you wanted to, you could have multiplied both the top and the bottom by the square root of 75 and you still would arrive at the same answer. You're just dealing with larger numbers. And if you are struggling with mental math, you may not want to deal with multiplying by 75. So simplifying first gives us smaller numbers to work with. We want to get rid of this root 3, and so we're going to multiply the bottom by root 3, and whatever we do to the bottom, we also have to do to the top. Multiplying across the top, we get the square root of 6, and multiplying across the bottom, we get 5 times the square root of 3 times the square root of 3. These two kind of cancel each other out. Squaring a square root cancels each other out, so we're just left with 5 times 3 on the bottom. That simplifies to square root of 6 over 15. We cannot simplify the square root of 6 anymore. So that is our final answer. All right, guys, here are your steps in rationalizing the denominator. I am quickly running out of time, so we'll go through these and then begin part 2. First, write both radicals in fractional form. Then simplify both the numerator and the denominator as much as possible, like we did with the 75. After you've done that, if there's a radical still left in the denominator, multiply by the form of 1. Form of 1 is, root 7 over root 7, or root 3 over root 3, a radical over itself. Multiply by the form of 1. That makes the radicand and the denominator a perfect power. Basically, that eliminates the root symbol. Simplify both the numerator and the denominator and reduce the fraction if necessary.